All right, so let's graph this rational function. So first thing we're going to do is look for domain. How do you find domain? Very good. Denominator not equal to 0. What's my denominator? Well, how do I solve that? Factor it. It's a simple trinomial. So x and x. Remember what multiplies to 3 and then read it backwards, subtracts to 2. Put your bigger number first. Bring down that first sign. And then positive 3 times what kind of 1 gives me that negative 3? And it's still not equal to 0. Then what do? Set each factor not equal to 0. And solve for x. Alright, so if you need to, remember, do your number line to help you with your intervals. If you don't need to, you don't have to. So at negative 3, it's going to be an open circle. And at positive 1, it'll be an open circle. But everything else is shaded. Doing that helps me see my intervals because I can see it's from here to here, and from here to here, and from there to there. Okay. So I know I should have 3 intervals with u's in between them, okay?
We're doing all 9 steps on this one?
Yes. So we have negative infinity to negative 3, negative 3, to 1, and 1 to positive infinity. All right, step 2, our vertical asymptote. How do you find your vertical asymptote? Uncancelled factors of the denominator equal to 0 means we need to make sure that this is all factored out. Well, we just factored the denominator in the previous one. In the domain, we said it was x plus 3 times x minus 1. But I got to factor that numerator as well. So again, it's a simple trinomial. So x and x. Remember, you're looking for what multiplies to 2 and subtracts to 1. Okay. 1 and 2, put your bigger number first. Bring down that first sign. So positive 2 times what kind of 1 gives me that negative 2 at the end? Alright, so we got both of them factored. Does anything cancel? The x minus 1's cancel, and we're left with... Alright. Excuse me. So remember you said your vertical asymptotes were your uncancelled factors of the denominator. Did anything on the denominator not cancel? The x plus 3. And you set it equal to 0. So subtract the 3. And we have a vertical asymptote at x equals negative 3. And we have holes. What are holes? They're your canceled factors of the denominator. Did anything cancel? The x minus 1. So it's the x minus 1 set equal to 0. Solve for x, so we get x equals positive 1. But remember, holes is an ordered pair. So I know it's going to be x is 1. How do you find the y value? Not the original equation, though. Yes, you're going to plug x into our simplified equation, okay? So we're going to use the x plus 2 over the x plus 3. If you put it back into the original, because it's a hole, remember that's a restriction in the domain, which means I'm going to come out with an undefined answer. So I'm going to plug in 1 for x. And we get 3/4. Alright. And step 4 is that horizontal asymptote. How do you find the horizontal asymptote? Look at the exponent. You're looking for that highest power of x. Where is it at? It's on both. So it's going to be a ratio of the coefficients. So what are the coefficients? 1 over 1, which is just 1. Good. All right, then we're not going to worry about slant asymptote. Not yet. It's coming. Then we have x-intercept. How do we find x-intercept? Numerator equals 0, right? So what's my numerator? Just the x plus 2. Use the simplified one. Because remember, if you use the original one, you're going to come out with an x-intercept at 1. But 1 is a whole, isn't it? So you got to use the simplified if it's available. All right, so we get x equals negative 2. All right, 7 is your y-intercept. How do you find it? Say it again. Set x equal to 0 and solve. So you use your simplified one again. So you have 0 plus 2 over 0 plus 3, which is 2 over 3. Good. All right, so 8 is our table. So we're going to have our interval, our x value, y value, and the sign. All right, so my intervals. What creates my intervals?
Your domain. Domain and your
No? Very good. X-intercepts and vertical asymptotes. So where's my interval always going to start at? Negative infinity. And then let's look at our x-intercepts and our vertical asymptotes. We have an x-intercept at negative 2 and a vertical asymptote at negative 3. Which one of those is smaller? Negative 3. So then it goes from negative 3 to, what's the next smallest one?
negative 2.
And then from negative 2, it's going to go to... Do I have any more x-intercepts or vertical asymptotes?
Infinity.
So it goes to infinity. Alright, so give me an x value between negative infinity and negative 3. Negative 5. What about between negative 3 and negative 2? Negative 2.5? Alright, what about from negative 2 to infinity?
0.
Alright, so what do we do once we find our x values? Plug it into the simplified equation to find the y value. So, I'm going to plug in negative 5. So negative 5 plus 2 over negative 5 plus 3. So negative 3 over negative 2, which is positive 3/2. And we said it's positive. Plug in your negative 2.5.
So are like all of them going to be like this?
Alright, so we divide these out, and we got negative 1. And so it's negative. Plug in the 0. Should look familiar. The nice thing about doing the 0 is you already did it. It's your y-intercept. And so it was a positive 2/3. Okay, and the last step here is our graph. So remember, we're going to graph all our pieces. So the first thing we have is we can't graph the domain, but my vertical asymptote at negative 3. So I'm going to go to negative 3 and put in my vertical asymptote. Remember, it's dashed. Keep going. We have a hole at 1 3/4. So I'm going to go to 1 3/4. I'm going to put a hole there. Remember, it's just an open circle. I have a horizontal asymptote at y equals 1. So I'm going to draw a line at y equals 1. Mine's a little low there, so I'm going to raise it, trying to stay away from that hole, though the hole's really close to it, so just know it's not actually touching it. Remember, it's dashed because it's an asymptote.
Is there any other way to show the hole?
No, a hole will always just be an open circle.
Oh, okay.
You have an x-intercept at -2. And a y-intercept at 2/3. Plot your points in your table. -5 and +3/2. Remember, +3/2 is 1.5. -2.5 and -1. And I already have my 0 and 2/3. Then we can see, because over on the very left there I have that point. So as I go to the left, that horizontal asymptote is going to shape it. And as I go to the right, it's going to force my graph to go up by the vertical asymptote. And then hopefully we can see there on the right side, just connect the dot, right? So as I go to the left, the vertical asymptote is going to force it down. And as I go to the right, I got to make sure I go through the y-intercept, and I got to go touch that hole, skip over it, and then it's shaped by that horizontal asymptote. And there's my graph.